welcome to our third day. Today I'm going to talk about ideas, inventions, and innovations. I will give you a short introduction to my person. I'm actually, sorry, my voice needs some little bit of time. I'm a research funding officer, so I'm working in science management, and my background is material science and engineering, but nowadays I work for all fields. I work for textiles, I work for chemistry, I work for social sciences, and in general, my job is to get money, so we're talking about getting money today in the afternoon, but first of all, we have to develop an idea which we can develop into an invention or into an innovation. So this is what we're going to talk about. We're going to talk about ideas, we're going to talk a little bit about inventions, and we heard a lot yesterday about innovations, but I would like to add some information about this as well. So if we start in looking how do we get to innovations, it usually starts with some kind of problem, crisis, or some special task. And then there are a lot of things happening. We have a lot of chances which we can investigate. We have to do evaluations, we have to build prototypes, and hopefully at the end we've got some innovation. And we will look at this process a little bit more in detail. So here you can see is how do we get from an idea to a solution to an invention. And there we have such a solution cycle. And the first step is that we have to identify what we would like to investigate and what would we like to elaborate. And the second step is going to be clarify, because we have to be really certain what we are talking about and that we are talking about the same problem. And then a big part today is going to be the solving. How can we solve a problem? How can we get new ideas? Then another big step in the process, but not today, is plan, implement, flow in evaluation. And so you can think of your problems you have in every day. Which problems do you occur during the day, in your personal life, during work life? For me, for example, it is at 4 p.m. in the afternoon, I'm hungry, and at my university there's no food. So what do? I'll go home. That's like my first idea. I'm hungry, let's go home. So what problems do you occur?
Ironing.
What? Ironing. Oh yeah, that's a problem as well.
The bus, the transportation, and sometimes it's late or you are in trouble.
Yes. And usually if you have some problem, you've got an idea and you just do it. That's an unusual approach when you have a problem, because you have so many problems and you take usually your first idea or the first best idea. And today we're going to talk about if we can get better solutions, if we put a little bit effort, brain effort into it. So the first step, if we have identified a problem, we really have to talk about what really exactly is the problem. So we really have to clarify it, especially if we have to investigate or evaluate this problem with other people, because they may have a different understanding. And so here see in this sample, you see what the customer described, and you see what another person defined, what the person of the sales did, what the construction designed, what was tested, what was fabricated, what the assembly installed, how the customer used it, and what was invoiced, and what actually the customer wanted. So you see that people have different approaches, they have different things in mind if they are thinking about a certain thing. So you have to really make sure that you clarify your problem and try to describe it. So we really have to have a precise description of the problem, or the requirements, or the function is necessary. So we can take, for example, a cooking pot. So what do you think is the functions, or what are the functions of such a cooking pot? Heat the food? Yes, okay. What else, maybe? To store food?
Sterilizing of small particles in the lab.
Yeah, so if you think of... Yeah, so if you think about, we can define it a little bit more in detail. For example, we can talk something about the isolation heat from the environment, to be a little bit more specific. We also maybe got the function transport of the pod, so this is why it usually gets to Griffe, where you can hold it. And so that's really important that you really make sure that you know all your functions, or you have to really clarify your problem. And a function is the abstractly described general cause effect of a relationship between input, output, and the state variables of a system for the fulfillment of the task. So you see, this is a quite difficult description or definition, but this is because function description is an abstraction method, and this is something special humans can do. They can think abstract. They do not think in similar ways, but they can abstract things. And the aim in the step of clarifying is that you really detach yourself from the object, and this allows you to find new and better solutions. So this is also another example of a function of a clothespin, and you can see that after somebody or some people defined the functions, that it has to hold laundry, connect the linen with the line, and also to release the laundry again. And you can see that people came up with different types of clothespin, just because they defined, first of all, the same functions. So what do you see on this picture? Yeah, a buffalo, exactly. And this is a great example of how people are able to be abstract or to think abstract, because these are all the different types and the sketches of a buffalo, and you can see that it all, well, we realize it because it's a basic sketch of what it should look like. Okay, so the next design task is develop a new bicycle frame. So how could you start with it? How would you approach such a task? What does a bicycle frame? Do you mean functions? And what are the functions? Oh, the wheels, exactly. Do you would like to add something? Yes, okay. But to hold the wheels, that's exactly the thing we would like to have a look at. And so we have to look where does the wheels need to be connected. And then you can see we need here at the back wheel, at the pedals. And so we can make these dots, and then we can see the abstraction. We just can look at the dots. And now is the question, how can we connect the dots? And if you would like to or try to sketch it, then you will get a lot of solutions how you could sketch connect these 4 dots, for example. So you have like everything is connected with everything, or it's connected in a zigzag or in a line. And if you look at real bicycles, you see that they have exactly similar things like this. So you see that if you abstract a problem and make it easier, for example, and then you can have a lot more possibility to gain a solution. Maybe some of these solutions are not mechanically stable, but at the first glance, they offer a solution, which you can have a look at. So, and if we would like to solve problems, I have 2 quotes. One is from Albert Einstein. He said, "We cannot solve our problems with the same thinking we used to when we created them, so we really have to find a new approach." And French philosopher Émile Chartier said, "Nothing is more dangerous than an idea when it's the only one we have, because usually you can think about it and then you can find more solutions or ideas for it." So the question is, how do I come up with new ideas, or how do we up with new ideas, and how do we find solutions? So do you know this riddle? So you have these 9 dots, nicely arranged, and you shall connect these 9 dots with 4 straight lines without putting down the pencil. So you could try if you can do it. Yeah, thank you. Did everybody know about this, or does somebody stuck with this first? You? Did you already knew this riddle? Yeah, yes, you, because you was drawing in the air. Yeah, but what is within the middle? Diagonal, yeah, exactly. That's what yes, I didn't saw it when you were drawing in the air. Exactly. And this is it, what already was said. You have to think out of the box, really, because you really have to not think, oh, I have to draw my lines inside the box. We have to free your mind from some intuitive boundary, or maybe boundary which you have, because maybe somebody said, we did it this way. You really have to think out of the box, think with a fresh view on it. So if we talk about creativity and find new solutions, basically everyone can be creative. Everybody was a child of us and was curious and trying to get an idea of the world or how the world works. And so everybody is able to be creative, maybe more, some people less. And I would like to talk about some methods which can positively influence your creativity thinking, especially if you're working in a group. So here you see another example of creativity barriers. So here are the people, they are running away. If a switch doesn't come soon, we're doomed. They could just jump aside, but they are running and trail. If you're trying to be creative, we have maybe a problem because we are fixated, we have difficulties because we're mentally detached to our known technical systems. Sometimes we really have to free ourselves. And also it's important that knowledge and experience is important for being creative. So please always look out what's around the world, what's happening in other fields with your friends. Maybe it gives you some ideas. And also the interpersonal level is important to consider because interactions between people can strongly hinder the creativity of individuals. Like, for example, if you're sitting in a meeting with your boss, if you're a shy employee, you may not say all your thoughts because your boss is maybe really strict or something, or you assume something. So this may be something which you always have to consider to make sure that you have a free space where you can talk about your ideas. And like we said, with the abstraction, creativity arises from the distance to the problems. Really have not to focus on the problems, a step aside back, and then you can have a fresh view to the problem. I'm think fast. So there are a lot of methods for finding solutions, promoting creativity. And we could think about collecting, which means that you can go to customers, ask them about their opinion. Competitioners, you can have a look what they are doing. You can have a look at already established products, patents, literature, measurements. But we're also going to talk about some creative methods and systematic methods. Some of them are similar, some of them are really special, and you have to put a lot of time into it to get to know them. But some of them we are going to talk today about. So the first thing is brainstorming, and I guess everybody of you know brainstorming already, or? Because I guess yesterday when you had your exercise with the marketing strategy, that was basically the same thing which you did. You all stood together in a group and everybody said what he had in mind and you came up with ideas and it was a nice setting. Nobody said, oh, you're wrong. And this is a good example for brainstorming. And usually it's easily done. You usually have a small group of people and it doesn't matter if they are professionals or amateurs, and usually have some time period. And the rules is basically free expression of ideas. And really the important thing is, no matter what kind, and usually after the meeting, after everybody has put this idea together, the next step is to evaluate, to take some time, look at the ideas, what you already did yesterday. So first of all, you sketched all your ideas, and then you talked about what you just sketched. And if you're looking at the implementation phase, you usually need a preparation phase where you announce the problem. You remember when the lady was standing on the stage and was introducing you to the problem. She defined the problem, gave you some instructions what to do and how to do it. And then you enter into interpretive phase where you express and record your spontaneous ideas, your mutual inspirations. And at the end, there was the evaluation phase. And so we have idea production and idea assessment. And it's really important that we separate these two phases so that we can make sure that we get a lot of ideas and not directly say, ooh, that's a bad idea, we've never done this way, he wouldn't like it, she wouldn't like it. It's really important that we really have these two steps when we try to produce new ideas. And here we also have a moderator who looks at you that the process is going. So sometimes some of the lecturers went to your groups and listened a little bit to you, and sometimes they try to focus you on the work, say, oh, this is the time limit. And he also makes sure that nobody is harming or harmful to the others. So the moderator usually has some special role, and he's not participating in this idea brainstorming session. And the moderator really is like an outstanding person. He is not a master idea generator. He has no active participation, and he just looks at everything once the way it should be. And what happens in such a brainstorming, there are some so-called killer phrases, which we would like to avoid strictly. Can you imagine what these sentences are, what we do not like to hear in such a session? If you're thinking about ideas and everybody is saying something, new ideas, what is something bad, what should be avoided? Laura, please? Yeah, this is wrong. What else could you imagine? Yeah, you're stupid, sorry, you again. Too expensive. Yeah, exactly, and we can think of a lot of these things, like can't, no time, not financeable, directly talking about finance, maybe it's financeable, you never know. We have already tried it X years ago, it's too old-fashioned, it's too modern. Yeah, you have probably not understood our problem, or as an expert I can tell you. Really funny things happen when you have such a brainstorming session and people are skeptical about it. And this is really something we would really try to avoid, and that's also the job of the moderator, because intuitivity, we say something like this, no, but really first collect all the ideas. Everything is okay, as long as it's not an insult. Everything is okay. So collect all the ideas first. And this is like a short sketch if we're making like a brainstorming session, 20 or 30 minutes. This is a basic sketch how the ideas come out of the group. So at the beginning, it starts. New ideas coming up, and the other people are, and I think of this when I hear that, and they come up with new ideas, and then it slowly falls off. After a time, everybody has put a lot of effort into this work, and then are coming less ideas. But out of experience, after thinking of a while, more fancy ideas come up to task. But maybe it even can happen that one of the ideas from the beginning is like the best idea at the end. But usually you should take some time to get also some fancy ideas maybe at the end. So if we're thinking about brainstorming and look at the advantages or disadvantages, who would like to say what an advantage of brainstorming is? Can you think of one? Sorry. Oh, sorry. Sorry. Okay, so can somebody think of advantages? Great ideas, okay.
Participation of everybody.
Yeah, participation of everybody. What else? Different points of view. You get easily different points of view. And can you think of disadvantages? Too chaotic? Yes, maybe, yeah. Too many different ideas, okay. No? Okay. Yeah, maybe for shy people, they do not would like to participate in such a discussion. So these are some advantages and disadvantages. It's especially good for solving a clearly defined smaller problem. So a solution for the climate crisis can be done in a brainstorming session. And it often provides many approaches. It's well known and easy to implement. Everybody understands the principle and it's easy to follow. And it's applicable to problems for which no ideas exist yet. And disadvantages are, for example, shy people may not be comfortable in such situations. And the group often runs fast in one direction because they're not stepping aside and thinking of a new view on it. It's not so good for complex problems, and the rules of brainstorming are sometimes difficult to follow because we tend to say, oh, no, that doesn't work, we tried it last year. And also these personal hierarchies may hinder a good brainstorming session. So we can use a different method, and it's called the 6-3-5 method, which is, instead of talking about the problem, we write about the problem. So we have a written problem statement, and hopefully somebody prepared 6 sheets with 18 squares. If we're doing the 6-3-5 methods as it was invented, we have 6 participants. They can be professionals or employees of the same level, and we have like 6 participants, and 5 minutes is each round. So everybody sits together and have a sheet in front of you, and 5 minutes he has time to put his idea to the paper. And after 5 minutes, the sheet is passed around, and every sheet is passed around to the next neighbor, and then the next person has the task to write new ideas to it. And you have to write 3 ideas. That's why it's called 6-3-5. And this goes on after 6 passes till everybody wrote something on a sheet. And every time you get a new sheet from your neighbor, you see what he has or she has written, and then you get new ideas maybe and think of it differently. And this is how it works. And also after the session, after everybody put his ideas into these sheets, somebody else probably is going to evaluate it. So what do you think are the advantages and disadvantages of this method? Yes? Too short time, okay. No discussion, yeah, okay. The same, okay.
Very rigid, no?
Very rigid, yes, yes. You have to think in boxes, and you have to write your idea in these small boxes, and maybe you use somebody who would like to talk. So it's really difficult if you would like to sketch it. But similar to brainstorming, it's good for solving clearly defined smaller problems. Here, the advantages is that you have no killer phrases in early ratings critics, because you have like 5 minutes and you're reading the idea and your task is to write 3 new ideas. You have no time to mark the comments of the other people and say wrong, wrong, wrong. You have no time for that. So these killer phrases are avoided. So we also have no early ratings or criticism. If we calculate, we can get up to 100 ideas. Sometimes the ideas are doubled, so maybe not all 100 ideas. It's very good for shy participants, and it activates all participants. So because sometimes in a group of people tend to let the leader talk, and not everybody is talking equally. And this is a way that everybody has a chance to put his idea into the group. Yes, everything which is usually happening in a group is here avoided. And we have short time, which was mentioned already. You could also make it decentralized by email or something, giving everybody a task, and then the next day, again, 5 minutes. Yes, disadvantage, bad for participants who are not good at sketching. So if you do not like to write or not like to sketch, sometimes too little time, 5 minutes, and you have an idea and you would like to precise it, makes it hard. And also, which I think is a downside, the spontaneity of this method is a little bit lower. So usually if you hear some idea from another person, you have directly something makes click in your head and you have the next idea. And if you write something, this is really slowed down and it takes a lot of time to sketch instead of saying something and using your gesture and mimics. So a similar method is like brain whiting. It's a mixture of brainstorming and 635, and basically it's combining the advantages and the disadvantages of both of these tasks. So we have a lot of pens and cards and boards, but it's not as strict. It's not like everybody has 3 tasks to write. They're all sitting in a group, everybody writes. It's a little bit more open. Yes, but it's basically it's like a mixture of both of them, and thus we can have like both advantages and disadvantages of both of these techniques. So, and if you're thinking about creativity tools, it's really important not to stuck with words, because a picture paints 1,000 words. So you should not only use text, you should use idols, slogans, quotes, symbols, sketches, analogies from different areas, whatever comes in your mind, whatever will you're familiar with or comfortable with. Some people like to sketch really a lot and complex stuff, and I have some colleagues, when I work with them, they are sketching some circles and everything, and yes, and that's good because you think with a different view on it, and it's really also important to use different perspective. Think of if you would be the customer or the user, or if you're a developer, you can also think about, oh, I'm a really critical person, and go with this approach, or being an utopist and think, oh, everything is possible. Really try to use all your personalities you have to approach problems, and especially use all the personalities in a group. It's not that one person or one approach is the best. It's best if we're having different approaches. So here you can see something which you probably already did when you're working some tasks for university or whatever, is mind mapping. It's a little bit more structured, and it's a method where you can work alone or with a group of people, and there you can use and everything of these tools to visualize it. You can, what has a mind map is had structure. You have these different branches with words which are connected and belong together. You have lines, you can use words and images, and I think everybody of you somehow already used a smaller or a bigger mind map. That's a typical technique to get an idea of a problem and to specify it. Yes. So, I need to drink something. And another way to approach a problem is using bionics. That means you're using inspiration from the nature. And so usually you should have people who have good knowledge of nature, and then you have a group maybe of people with knowledge and some unexperienced technical people. They're sitting together and they think about, how is nature solving this problem? How can we solve the problem? It's a little bit not so strictly in time. It's usually a group meeting, and it's a lot about discussions. How could we do it? And do you know some bionic examples where people used something from the nature to solve problems in real life or in real technology? Yes, aircrafts. What else? Architecture, yeah, like all these branches and how everything is going to be stable. Yes, yes. Something more? Sorry. Yes, nice example, yes. So, and if you would think about a little bit more, you would come up with a lot of ideas because a lot of people already have a lot of ideas. For example, suction cups, I like the arms from the octopus. Even a salt shaker is visually copied from a poppy seed capsule. It's the same principle. A really nice example is gecko food, how it is used for glue or something, or some special techniques. Something which is also well known are the Velcro fasteners. It's come from a plant, and so you can think of a lot of ideas. And the nice thing, it's still a very valuable source for inspiration and invention. That's why for a couple of days ago, the German federal ministry sets off another call, and they said, I give you money, or we give you money if you solve problems, if you use such techniques, if you're using super hydrophobic surfaces, coatings or structuring of surfaces, or if you use self-regulating material, which is bio-inspired, self-regulating, self-healing materials, self-organizing materials, self-regulating shapes. So it's still really a valuable source for inventions and ideas. And if you have an idea, come to us. We in Germany, we can get money if we're making projects with you. And another task, I hope I do not overload you, but I would like to give you a lot of different aspects how you can approach such problems. Another one would be the reverse method. That means we're not trying to find a solution for the problem. We would like to make the problem even worse. So we can make it by the reciprocity principle. That means the quantity of interest is described by its reciprocal value. We can make a negation principle. We can use the question, what must be the solution not to be able to do something? Or we can make the principle of inversion. The opposite is searched for. So an example would be, the question is, how do I prevent a burglary in a house? Yes, a difficult task. But if you reverse this problem and you say, how do I plan the perfect burglary? You exactly know where to make your house safe, what to do, and how to make a house really safe. And you could really try also this task with other problems. If you really think of a different point of view, or really try to make the opposite or make the problem even worse. Okay. We also could go and approach problems a little bit more systematically. So here's an example of a systematical analysis, which is called morphological analysis. And morphology is the doctrine of ordered thoughts. So we have a really big problem, and it's really diffuse. And what we are doing with our big problem is we're going to divide it into a bunch of sub-problems, and then we can focus into our sub-problems. Hopefully, they are easy to solve. So if you're looking at an example, for example, we would like to write a crime novel or a TV show about crimes. And so we think about different sub-problems. So for example, we could have the place, which could vary, which is one part which you have to have a look at. We need to have a victim. We need to have a hero. We need to have a villain. We have to have a cause of death. And we have a motive. And somehow this crime needs to be uncovered. And then you think, first of all, of these different categories. And then you can think of different items or solutions for these sub-problems. And then, at the end, you can make your connections and see if at a lecture hall with a professor and a doctor and a friend and a poison instinct, and by coincidence is uncovered, maybe this is a good story. Maybe it isn't. Maybe it makes no sense. And also you could think of a lot of different stories and try to get to the solution of an idea. And you could even use it for technical problems. For example, if you have an alarm clock, and then you can think, what are different categories for an alarm clock? What does an alarm clock has to do? You have an answer, you're smiling.
The first one is to wake up you, no?
Yes, and how does it do it?
Put the time. Do you want
Yeah,
to-
you have to have the time, and what else do you need to wake up you? Because if it just shows the time, it's not going to wake you up. So what does it have to do?
Well, you need some noise, no? I mean,
Yeah,
to
a signal or something. And then you kind of, how could you get the time? You have quartz, you have sun clocks you could use your chicken in the garden, maybe, and you can think of how to make noise. You can use, again, the chicken, and you could, what kind of noises can you use for an alarm clock? Could be an electronical noise or some mechanical noise. So you see, even if you have some technical problems, it's really worthwhile thinking in this morphological system and try to find sub-problems and the solution to smaller problems. So here again, we have it written how it's done. We have, as a prerequisite, we have to announce the written problem in advance. We have a team size of about 5 to 10 persons, because if a group is bigger, not everybody is going to participate, so this is a good size. Time frame is undefined, and you clarify and specify the task. You create your functional structure, define your sub-problems, and then you enter really, like I showed you, sub-problems line by line and finding solutions to every problem line by line. And hopefully at the end you can combine partial solutions, and some of the ideas may be working, some of the ideas may not work, of course. So here you can see the advantages and disadvantages. As an advantage, we can proceed systematically. So it gives some impression that you really capture the problem and not just some parts of it which you're just thinking on, but it gives you the opportunity to make it really systematically and hopefully satisfy an engineer if he can approach something systematically and not be creative. But you have to make a complete problem analysis. Misunderstanding in team needs to be avoided. So there are a lot of advantages. And disadvantages are the solution structure is dependent on the function structure, so you really have to think about your structure, functions at the beginning, but often low alienation or abstraction of the problem is achieved because you're really thinking in a system. You're not thinking freely, you're thinking in boxes, in these smaller problems. This may be a disadvantage. So, and if you now spend a lot of time in solving the problem and trying to find ideas, the next step, of course, is planning. And there's a quote from Albert Einstein. It was sometimes quoted in this way, sometimes a little bit differently. And he said, if I had 1 hour to solve a problem that my life depended on, then I would spend 40 minutes analyzing the problem, 15 minutes reviewing the solution to the problem, and 5 minutes implementing the solution. So the first step, planning, finding ideas, thinking about the idea and the plan should consume a lot of your time. And if you have put a lot of thoughts in it, the implementation should be easy and not use so much time if everything's fine. And so these are the steps: plan and implementation, and I would like to focus on these ones. The next step, if you started with your task and trying to, if you're trying to master your task, then you're always in some. Yes, you have some two different aspects. You can have competencies in the task, and a task can be really challenging. And depending if a task is more challenging or you have more competence in it, you can be either bored by your task or you can be really stressed by your task. You can get really excited about a task when you have a task. Ooh, this is really, really difficult, but I'm a really clever person, I can do this. Then it's excitement to do even difficult tasks. And this means if you really in a balance between challenge and competences, then you're like in a flow balance. Then you forget your time if you're working on something. And this is a really good state where you should put your tasks so you can make them run. So do you know examples for yourself where you are in a flow and can easily work? What are your examples? Not always you. Yes, please. Okay, writing, nice. I'm not getting in flow when I'm writing. What about the other people? Yeah, presentation, for example. What else? Everybody should think of something. What puts you in a good mood? What's some nice, challenging task but you like to do? Working in the garden, sports, for example. My colleagues make fun of me because I'm sitting at Excels and put formulas into it and make it better and automatically so that you don't need to put anything by hand. I really like to make really complex Excels and protocols, how to calculate something. And you really should think about what are your flow tasks, because these are the tasks where you're also getting good results, because you're really excited and not bored, but also not feared, not stressed. So after you finish the task and have written a lot of text, you're feeling good because you have achieved something, and you have usually achieved a lot of good stuff. So this is where you should put your mind in it and put your task and work in it, and all the other tasks you should give away to other people. Yes, you should really do that. Okay, so after you had a solution to your task and try to implement it, you of course shall evaluate it. So you should determine if it's really the best possible solution to the problem. You have to decide how you will quantify it, how you measure your success, how effective was the solution. Did you really achieve what you wanted, or is it just a little bit better, but you really wanted the best solution? You really have to set some measurements, and if you reached your goal, great. And if you feel dissatisfied with the result, you have to try alternative ways or arrange yourself with the problem. But you could then begin the problem-solving cycle again and think about new ideas, define the function a little bit more different, and then you could come up with new ideas. So if we watch again our solution cycle with identifying, clarifying, solving, planning, implementing, flowing, and evaluating, here you can see that for different tasks, different people or different personalities maybe have a good approach to it. For example, if you would like to clarify something, somebody who's good at observing something and good at describing a problem is a good person you should work with. Or if you're working at solving, you should use people who are creative or open-minded at least. And if you have somebody, you have the task implementation, you should really take somebody who's likes to make things, like an entrepreneur. He's also like to make things. And this is an example what people you could use. So, and if we run through this cycle and evaluated our solution, and if it works and if it's new, then we have an invention. Then we made out an idea in our head, we built something, a prototype, and we showed that it's working, and then we have an invention. And if we have inventions, we can categorize them to the technology readiness level. Do you know this scale? Is it familiar with you? No, it's not, but it is an often used scale in research and development because it says how you get from research to the market, which different steps you have to take, or which different steps are there, and this scale is often used in science management. So at the beginning, we have an idea just in our head, an unproven concept, and no testing has been performed. That's like stage 0 or level 0. And the next step is a basic principle was observed and reported, but no experimental proof was available yet. So no really basic calculations, some physics in his lab. And the next step is a technology concept or an applied formula. And the next step is the proof of concept. It means the first time somebody was in the lab and tested it, and the test was successful. So if you're thinking about the next step, then you get to demonstration that it really works, and it works in a larger environment. That means you're getting from small-scale prototype tested in a lab environment, and then you're getting to a large-scale prototype in an intended environment. You're getting a prototype system verified, and then you're getting a demonstration system in operational, environmental, pre-commercial sales scale. And then, in order to get from a demonstration, from a prototype to the market, you have to have a first kind of commercial system, or the manufacturing issues are solved, and then you have the full commercial application technology available for consumers. And it's really usual in research and development to use these levels to describe where your research is. So you have, for example, basic research, which is really here in the field of research. And when you're getting to applied research or development, you're getting a little bit higher. Or if you're working with industry, for example, you're getting to TRL 8 or 9 because they really would like to make something putting on the market where you really, every problem is solved and you can make money with it. And because the scale is a little bit abstract, sometimes it's easy to find some examples for here and there and this. But I have an example for a development of a technique, which is the transrapid. And you can see that the first research for that was electromagnetism was observed and studied and written into formulas. And it was done in the 1900s. And then the next step, somebody was able to control repulsion of electromagnetic fields, and levitation of first small vehicles was patented around 1900. And then the proof of this repulsion was done between the fields. So this is really basic science. And then the next step was the building of magnetic levitation in an enclosed space, and then there were some test tracks with the transrapids, and there was a pilot route, but it's still not that you can go to the train station and use a transrapid, but after a while you see that it's coming, this technique to the market. But you see it can take a lot of time from your first idea to the market. And so it's really important to have some steps in between which can see and verify that you have progress in your research. And if you're talking about inventions, we can also see that we also have to look at money, of course, the accumulated profit and loss over time. So at the beginning, you have your research, so you have to put money in your research, and then you would like to develop it even further, which means you put even more money into it, and you're not getting money out of it, so you have to invest it. And just when you're starting to write your business plan and think about commercialization and success as a business or as a product, you really have to have money in order to later on get money out. So research is always an investment and a risky investment. So you always have to keep that in mind. How much money do you invest in something, or how much money do you need in order to bring your idea to the market and make it successful? So, and if we were successful, if we put it on the market, then we are going to talk about innovations. And innovation is like a buzzword which is used all the time. You hear, I'm an innovative person, this was an innovative idea. So let's look again what innovation means. And this is novus, means new, it's Latin, and innovatio means to create something new. And the actual definition of the word innovation means an invention which is successful on the market and in business terms. So not because you just invent something and have an invention, it's no innovation because it's just a technical solution to a problem, but it's not necessarily innovative because it's not special enough or you don't get money out of it. That's a characteristic of innovation, that you get money with it, that you can make money of it. So this is really often misused a term for it. So usually just in retrospect, it's possible to determine whether something is actually an innovation or it was just an invention. So can you think of innovations in your life which are really innovations, which are really inventions that changed your life? People make money with it. Can you think of something which is really innovative? Yeah, okay. Smartphones, of course. Internet, exactly. There are a lot of things. For example, here are some things like cell phones, not just smartphones, but before that there were cell phones. They were quite new. Walkmans, obviously it was a status symbol for urban lifestyle. It was really important to have something like this. I don't remember. Email, digital cameras, contact lenses. I really like the idea of not wearing glasses and having some small plastics in my eye and see everything. And there are some more examples. Can you think of inventions or something which was hyped as innovations but didn't make it really successful? Do you have an idea? Or something which was on the market, made some little amount and then disappeared?
MP3 player.
Yeah, a really good example. What else?
Polaroid.
Polaroid.
Now it's coming back.
Okay. What else? Oh yeah, everything in the 80s. Yeah, I remember my parents told me they bought 2 different video systems because they didn't know which one would be successful. So they invested money in both of the techniques, and I can imagine that you invest in both techniques. Yeah, you could say, because it was just a short time and then a new thing came which is more innovative or really changed something. Or also the Concorde, because it had some problems, the Zeppelin, house robot. So there's just other examples I found and I wanted to share with you. Okay, so connecting to the talk yesterday, we talked a lot about being an entrepreneur or being innovative. We would like to see what distinguish successful products, new products from flops. And that means we can look at the novelty and the uniqueness of superiority. So we have a high degree of innovation and novelty in the marketplace, and you really can see that with the smartphones. You have the internet right here. This is really something new and unique, and you don't have it somewhere else. And what else is important is knowledge of the target market and marketing expertise. It's market-oriented activities have to be done. You have to make research with your market, like test markets, for example. You have to make it customer benefit or targeted distribution. You have to take it in account. And you also have to use good marketing communication strategies to bring your invention to the people. You have to have expertise in research, development, and production, and you have a good, sufficient market size and grow. So if you're talking about an innovation, we can look at it at different views. It can have different dimensions. We can have the content dimension, which means what is new, what is the new aspect. The intensity dimension, how new is it? So we have a portable phone, but now it has much more battery life. So this is the intensity, which is new. The subject dimension, for whom is it new, for example, because some of the techniques were first developed for NASA people and for getting to the moon, and now they are techniques that are used for everyday people. The process dimension, where does the innovation begin, where does it end, and the normative dimension, does new equal successful, Does new equal relevant, meaningful, just because it's something new? Maybe it's not that special. So, and you can think of types of innovations. You can have product and service innovations, like a pen or telephone. You could have process innovation, which is just-in-time logistics, or electronic theater tickets, something new. Social innovations like job rotations, or employment program for job seekers, or management innovations. So if you're thinking about your field of research or study, can you think of some of inventions? So not like of your everyday life, but think about if your chemistry, what is in chemistry some invention you have or innovations you have seen? Synchrotron, yeah, okay. That's a really big one, okay. Oh yeah, CAD system, that's a nice example, yeah. Or data banks. I think data banks are a good example. You can reach them online and you could get all your information. And so you could really take some time, think about your research field, and get a little bit more view into what an innovation is. Okay, so I think that's one of the last slides, and then I'm finished. I would like to shortly talk about the characteristic of inventive research spheres, which means if you would like to have a creative, innovative milieu, then you have to make sure that there is presence. So many people can interact with one another, and you can overlook the people. So not too big, not too small, but they have contact. Another aspect, of course, is diversity for gender, for culture, or age, experience. Different point of views, maybe from gender or culture, can really influence and enlighten your creative work. And of course, exchange. You have to make sure that you have dialogues and forums. For example, there are companies, they make it possible that you can make a lunch meeting with anyone in the company. So even if you're like a technician, you can say, I would like to go to lunch with the CEO or CTO, and they make it possible that everybody can match with everybody. And that's, I think, a really nice example how to get people into dialogue. It's really important to have like a coffee room so people can meet, drink coffee. This is also important that you have some exchange, formal or informal. You have access to educational opportunities, involvement, and participation, and you have to have some free room or space in concerns of room, time, self-organization, or self-work. So to end my talk, I would like to give you 3 take-home messages. The one is about ideas. Anyone can be more or less creative, and maybe you just need the right technique. The next one, if inventions, a successful implementation of a new idea is an invention, and innovations strongly depend on technique, time, and material. So thank you for your listening. Too short.
Thank you very much, Jessica, for your inspiring presentation and innovative presentation. Questions for Jessica?
No.
Yes.
Thank you.
What is your favorite technique for innovations and why?
I think really contact lenses, because I wear them every day. And before that, I used glasses, and they're always annoying. If you're just lying down in your head and would like to watch a movie, they not nice. Or if you're going out and the water coming to your glasses, and with contact lenses, it's so perfect, and it's such impressive that some people make it so detailed, so precise, that it just have to pay some euros, not really much, to see so perfect. It's amazing. Yeah.
Okay. Any other question? I have one.
Oh.
Yeah, I mean, you're talking about, or you quote Albert Einstein several times, but Albert Einstein has innovation, but himself, let's say, with no brainstorming, not, he was creating, let's say, the relativity theory, just thinking, let's say, by himself. How do you put this way of thinking on creating innovative ideas within this frame, because it doesn't match with your collaborative frame of creating ideas. This is a new way, right?
Okay. Yeah.
How, I mean,
I think
it's a new way that also, I mean, it's not a new way, because the people normally create his own ideas by own self, but how do you compare, or how do you put in your scheme this kind of way of creating new ideas?
Yeah, I think he's an example, Albert Einstein, because he's a specialist in his field, and everybody of us is a specialist in his own field, but we're using the same techniques, and he has really used a lot of good techniques. For example, everybody who was a famous inventor really was a dedicated thinker and open-minded person, and tried to find solutions. For example, people tend to be more creative in certain situations, for example, under the shower or when they're going to bed to sleep, and some inventor also had usually something in his hand when he was in the evening resting in his chair, and all his thoughts coming to his mind just shortly before he sleeps, and when he falls asleep, his hand loosened and it clicked on the floor and he got awake, and then he can't remember this technique. So this is nice methods inventors use, and you should look at other inventors and to use their techniques and try them out for you.
Alejandro, this is still brainstorming, but with your own different personalities. This is like brainstorming between Mr. Jekyll and Dr. Hyde.
Any other question related with the innovation and creation and ideas? Okay. So let's thank us again, Jessica, for the presentation. Now.